Alright, gangsters, a new topic today is called differentiation. Differentiation is all about figuring out the gradient of a curved line or a particular point on a curved line, okay? Let's have a look at this curved line over here. If I were to ask a student, yo, what's the gradient of this line? Would there be just one answer? Does a curved line have a single gradient? No. Because let's say you were asked to find the gradient of the curved line at this point here. So I make a point. And one way we can find out the gradient is by drawing a tangent along that point. And then finding the gradient of this tangent. And have a look. This gradient looks pretty negative because it's sloping downwards. So this is a negative gradient. But then if I were to ask you to find the gradient at this point here, we'll draw a tangent. You notice the gradient is positive. The gradients are different. And then if I was to ask you to find the gradient at the turning point when it swaps from a negative to a positive gradient, or vice versa, which is this point over here, and we were to draw a tangent, you notice the gradient would be 0. So curved lines don't have a single gradient. There are going to be many gradients depending on the point along the curved line you choose. And in order to find the gradient at a particular point on a curved line, we use differentiation to help us. And let me show you how it works. Let's say we have a line, y equals 2x squared minus 6x plus 5. And someone says, yo, what's the gradient at x equals 4. So first thing, let's look at this graph I'm given. Y equals 2x squared minus 6x plus 5. You should notice that this is a quadratic. Okay, there's a squared term, a single x term, and a number term. So this is a quadratic. So this will be a U-shaped graph. Let's just draw a sketch like that. And the question is, what's the gradient at x equals 4? Let's just say 4 is here. It could be here, but just for an example, I'm going to say 4 is here. So we want to find the gradient at this point here. Well, we could draw a tangent, but since we don't have any scales, we can't actually do the rise and the run. So we're going to use differentiation to help us. So if you're ever asked to find a gradient of a curved line at a certain point, the first thing you have to do is you have to differentiate the equation. So we have to differentiate 2x squared minus 6x plus 5. Now, how do we differentiate? Super freaking easy. Me on this side. So I'm going to change color. We use that color already. 2x squared minus 6x plus 5. What you're going to do is first you're going to separate each term. So we're going to do it separately. So let's look at 2x squared. In order to differentiate, all you do is you always multiply the indice by the coefficient, and that will give you your new coefficient. So 2 times 2 is 4x, and you're going to and afterwards you subtract 1 from your indices. So 2 minus 1 is 1. So 4x to the power of 1, or just 4x. Okay? So now we've differentiated the first term. Let's look at the second term, minus 6x. For next one, if you ever have just a single variable x, you're just going to delete it. And it'll just be minus 6. And in the last term, the constant, if it's just positive 5, if it's just a constant, if you want to differentiate it, you're just going to eliminate it. Okay? So that's our final answer, 4x minus 6. We can say dy, this is the formal notation for differentiation, dy over dx is equal to 4x minus 6. Now, this equation is a formula for the gradient. So what you can do, if you want, you can replace this phrase dy over dx with the word gradient. The gradient is equal to 4x minus 6. And we're trying to find a gradient at x equals 4. So we can just replace this x with 4. So the gradient is equal to 4, x is 4, minus 6. Gradient equals 4 times 4 is 16, minus 6 is 10. So at this point here, the gradient is 10. And that's how you find the gradient of a certain point along a curved line. You get your equation, you differentiate it, and all you do is you plug in the coordinate you want to find the gradient of. Here we wanted to find the gradient at x equals 4, so I replaced x with 4. Okay, and that's it. Okay guys, before we start looking at word problems, let's just first practice differentiating a few expressions. So in a test, it might say differentiate the following equation, or it'll say find dy over dx. When the question says find dy over dx, that just means differentiate the equations. So let's look at the first equation, and let's write it out. So 3x squared, 3x to the power of 4 minus 2x squared plus 7. So for step 1, separate each term. We're going to do each one separately. Let's get the first term, 3x to the power of 4. So step 1 is you multiply the indice by the coefficient, and that will give you your new coefficient. So 3 times 4 is 12x, and then you subtract your indice by 1. So 4 minus 1 is 3. And that's your answer. That's your first term done. Let's look at the second term, minus 2x squared. So same thing, multiply your indice by your coefficient. Minus 2 times 4, minus 2 times 2 is minus 4x, and subtract your indice by 1. So 2 minus 1 is 1. So minus 4x to the power of 1, but we don't need that power of 1. So far, we have 12x cubed minus 4x, and let's look at that last one, positive 7. Remember guys, if it's just a constant is just a number by itself. To differentiate it, it just gets eliminated, so it's gone. So our final answer for this one will be dy over dx is equal to 12x cubed minus 4x. Okay, let's look at the next one. So differentiate or find dy over dx. So I'll write down all three. I'll write down the expression. What you're going to do is you're going to cut each term in half. Just cut each term into separate parts. Sorry, cut the expression into its separate terms. So let's look at the first one, x cubed. If there's no number in front of x, guys, what's the coefficient? X just means 1x cubed. So we're going to multiply the coefficients by the indice. So 1 times 3 is 3x, and we'll subtract the indice by 1. So 3 minus 1 is 2. Next one, 5x squared. Same thing, multiply the indice by the coefficient. 5 times 2 is 10, x, and subtract 1 from the indice. So 2 minus 1 is 1, which is not necessary. And then 6x. If there's just an x by itself with no indice, you're just going to cancel it out, leaving you just with 6. So our final answer will be dy over dx is equal to 3x squared, positive 10x, positive 6. And that's your answer. Last one, 4x squared minus 9. So cut it. So 4x squared, multiply the indice by the coefficients. 4 times 2 is 8x, and subtract the indice by 1. 2 minus 1 is 1. 8x to the power of 1, which is just 8x. And then the next term is minus 9. If there's just a constant, it just gets eliminated. So what do we have left? Just 8x. So dy over dx is equal to 8x. And that's how we differentiate basic expressions. Here are some practice problems you can try on doing a differentiation on basic expressions. Give it a try. Now let's learn how to differentiate some harder equations. Let's look at the first one. Y equals x plus 4 times x plus 2. Work out dy over dx. So we're asked to work out dy over dx. That just means to differentiate the equation. If there's brackets, it's a little bit hard to differentiate it. What you want to do, pretty straightforward, is you want to get rid of the brackets by expanding. Since there are 2 brackets, we're going to use FOIL to expand the brackets. x plus 4 times x plus 2. FOIL. First, you're going to multiply the first terms in each bracket, x times x, x squared. Then you're going to multiply the outside terms in each bracket, so the outermost brackets. Boom. X times 2 is 2x. Then inside, the innermost terms, 4 times x, 4x. And last, the last terms in each bracket, 4 times 2 is positive 8. And if we simplify that, it'll give us x squared plus 6x plus 8. And now we can differentiate it. Boom. X squared means 1x squared. 1 times 2 is 2x. Subtract the indice by 1. 2 minus 1 is 1. So 2x to the power of 1, basically just 2x. Plus 6x. Well, remember, when there's just a single x term, it just cancels out, leaving us just with 6. And if it's just a constant number by itself, it just disappears. So our answer is going to be 2x plus 6. Let's look at the next one. X to the power of 9 over 3 plus x to the power of 4 over 4. Just like how it's pretty hard to differentiate with brackets, it's also hard to differentiate with fractions. So how do we do this? Well, let's just understand what's going on here. It's x to the power of 9 divided by 3. When you divide something by 3, it's exactly the same as finding 1/3 of something. 12 divided by 3 is 4, and 1/3 of 12 is also 4. So another way of saying x to the power of 9 divided by 3 is to try and find 1/3 of x to the power of 9. And then for the second for the second term, it's x to the power of 4 divided by 4. Dividing something by 4 is also the same as finding a quarter of something. So another way we can say x to the power of 4 divided by 4 is find 1/4 of x to the power of 4. And now we've got rid of those fractions, and now we can just multiply the coefficients by the indice. So 1/3 times 9 is 3x. We'll subtract the indice by 1, so 8, plus 1/4 times 4 is 1x, and we'll subtract the indice by 1 again, 3. And this is our answer. So dy over dx is equal to 3x to the power of 8 plus 1x to the power of 3. All right, let's do some even harder problems. Y equals 3 over x squared. Okay. So remember, it's pretty hard to differentiate with fractions, so we have to get rid of that fraction somehow. Now, in order to do these set of problems, you have to have a good understanding of your indice rules, okay? I'll briefly explain how to do this here, how to convert this into an indice, but if you want a more detailed explanation and more practice, just go into that indice video I have as well. So in order to turn this into an indice and get rid of the fraction, we can write 3 over x squared as this. 3x to the power of negative 2. Another example, if you had 5x to the power over negative 5, we could write this as 5x, and negative 5 becomes positive. So that's step 1. Get rid of that fraction. So it's 3x to the power of negative 2. And then now we can differentiate it. 3 times negative 2 is negative 6x. Negative 2 minus 1 is negative 3. And that's our answer. Next one. 4x times x cubed minus 2x over x squared. First, you want to get rid of the brackets. So let's expand the brackets. So 4 times x cubed and 4 times 2x. 4x times x cubed is 4x to the power of 4. And 4x times 2x is minus 8x squared over x squared. Then, oh, look, there's 3 terms. Each term has at least 2 x's. So we can cancel out 2 x's from each term. So if this has 4 x's, we'll cancel out 2 x's, which leaves us with 2 x's only. We'll cancel out 2 x's here and 2 x's here. So we're left with 4x squared minus 8. And now we can differentiate it. Dy over dx equals 4 times 2 is 8. X 2 minus 1 is 1. So 8x to the power of 1, basically just 8x. And minus 8 is a constant, so it just disappears. And this is our answer. Next one, differentiate the square root of x. Okay, indice rules are also required here. It's pretty hard to differentiate with surds and square roots and roots or cube roots. We have to get rid of this root somehow. Another way we can write the square root of x is like this. X, when you square root something, guys, you're basically rooting it by 2. What two numbers make x? So we're rooting it by 2. Our denominator is 2. And then x is just by itself, so it's just being powered by 1. So it's being powered by 1. So square root of x is basically x to the power of 1/2. And now we can just differentiate it. dy over dx. X is just 1, x. So 1 times half is half x. And half minus 1 is minus half. And that is your answer. Last one. Here I see a root. So let's get rid of it. So we can write this as x. Well, it's being rooted by 7. So that's going to be our denominator. And it's being powered by 2. So it's our numerator. And now we can dy over dx it. X is just 1x. 1 times 2/7 is 2/7. And 2/7 minus 1 is minus 5/7. And that's how you differentiate it. So as you can see, guys, indice rules go hand in hand with differentiation, especially when it comes to harder problems. So make sure you have both concepts down. And on the next page, you can give it a pause and you can try 4 questions over here. Now, let's start applying differentiation to some word problems. And differentiation can help us find the gradient of a point along a curved line. And let's see how that works in a question. A curve has equation y equals x cubed minus 5x squared plus 8x minus 7. Find the gradient of the curve at 2, -3. So, we have a curve with the equation of y equals x cubed minus 5x squared plus 8x minus 7. Let's just draw a sketch of this curve. Because the largest power is 3, this is definitely a cubic graph. And since it's a positive x cubed, it'll be a cubic graph that looks like this. So positive x cubed looks like this, and negative x cubed, if you were to have a question like that, would look like this. So our graph's positive, so it looks like this. And we're trying to find the gradient of the curve at 2, -3. Now, since this is just a sketch, I have no idea where 2, -3 is. It could be here, or here, or here, or here, or here. I have no clue. Let's just say, for the sake of this question, 2, -3 is here. That's 2, -3 at this point here. I want to find the gradient of the curve at this point. So basically, if you were to find a gradient of a point along the curved line, you have to draw a little tangent, and we have to find the gradient of this tangent. That's our goal. If we're able to find the gradient of this tangent, that will give us the gradient of the curve at this point here. Whenever you're given a question about a curved line and gradients, your first step should be to find dy over dx. Let's go ahead and differentiate this problem. So x cubed minus 5x squared plus 8x minus 7. X cubed means 1x cubed. So let's start differentiating. 1 times 3 is 3. X. 3 minus 1 is 2. The next term, minus 5 times 2 is -10x. Subtract 1 from the indice. 2 minus 1 is 1, which is just -10x. Next term, plus 8x. X is by itself, so it's just going to be plus 8. And -7 is a constant, so it just disappears. So we've differentiated it. Now, guys, you can always replace the phrase dy over dx with the word gradient. So instead of writing dy over dx, I'm going to write the gradient is equal to 3x squared minus 10x plus 8. Now, I want to find the gradient where the x-coordinate is 2. Because we're trying to find the gradient of the curve at 2, -3. So the x-coordinate is 2. So all you have to do, guys, is replace all the x values with 2. So the gradient is equal to 2 squared minus 10 times 2 plus 8. Gradient is equal to, let's go ahead and solve this. 2 squared is 4 times 3 is 12 minus 10 times 2 is 20 plus 8. 12 minus 20 is -8 plus 8 is 0. So the gradient at 2, -3 is 0. So we actually put our point 2, -3 in the wrong place because our tangent is definitely a positive tangent, but our gradient should be 0. So actually this point should not have been here. But remember, I was just doing it as an example to help visualize the problem. It should have actually been either here or here. Because if I were to draw a tangent at this point, it would be a gradient of 0. It's a flat line. And here as well. So 2, -3 is either at this point here or this point here. Now, what does your answer to part A tell you at about the point 2, -3? Guys, whenever you have a point which is at the top of a hill or at the bottom of a hill, we call it a turning point. So 2, -3 is a turning point because before our point 2, -3, the gradient is positive and then it becomes negative. And then before this point here, the gradient's negative and becomes positive. So 2, -3 is a turning point. Let's look at the next question. For a curve with equation y equals x cubed minus 3x minus 1, find dy over dx. Okay, let's just differentiate it. Dy over dx equals, let's write it out bigger. X cubed means 1x cubed. So 1 times 3 is 3x. Subtract 1 from the indices. 3 minus 1 is 2. -3x. X is by itself, so we just cancel out the x. So minus 3. And minus 1 is a constant, so it just disappears. So we differentiated it. Find the gradient of the point where x equals 4. So just to help us visualize this problem, I'll sketch it. So this is a cubic graph because the largest power is a 3. And since it's positive x cubed, it'll look like this. Now, we're trying to find the gradient of the curve at the point where x equals 4. So like the last question, guys, I've just sketched out this graph. I have no idea where x equals 4 is. Let's just say it's here. So we know at this point the x-coordinate is 4, and we don't know what the y-coordinate is, but that's not important anyways. And we're trying to find the gradient of the curve at that point. So let's draw a tangent. And then, remember guys, we can replace the phrase dy over dx with the word gradient. So instead of dy over dx equals 3x squared minus 3, I can say the gradient is equal to 3x squared minus 3. And since I'm trying to find the gradient of the curve when x is 4, I'll replace this x with 4. So g is equal to 4 squared minus 3. And we'll just solve for g. So indices first. 4 squared is 16, times 3 is 48, minus 3 is 45. So at this point, the gradient is 45. And that would be your answer. On the next page, guys, are some practice questions you can try in your own time. Give it a shot. Okay, guys, now we're going to do the opposite of what we were doing in the last chapter. Instead of being given a point and asked to find the gradient, we're going to be told that there's a point with a gradient of perhaps 12, and we got to find that coordinate. And let's look at how to do this. Find the coordinates of the points on the curve y equals x cubed, where the gradient is 12. So we have a graph. It's y equals x cubed. Since it's a cube graph, it's going to be cubic, so it'll look like this. And we're trying to find the coordinates of the point or points where the gradient is 12. All right. So there's some point where the gradient is 12. Where let's try and sketch where that point kind of looks like it'll be. Well, I think it's going to be here, perhaps. Because if I were to draw a tangent at this point, this looks fairly positive. It looks like it has a gradient of 12. Perhaps it could also be here. If I was to draw a tangent, this also looks like a gradient of 12. There could be 1 point or 2 points or multiple points. We're going to find out. So how do we do this? Just like before, if you ever have a curved line and there's a question referring to gradients, your first step should be to differentiate. So dy over dx equals, let's differentiate x cubed. X cubed means 1x cubed. 1 times 3 is 3. X, subtract 1 from the indices. 3 minus 1 is 2. Next, we can replace the phrase dy over dx with the word gradient. So the gradient is equal to 3x squared. And we're trying to find the coordinate. So basically, the x and y coordinate when the gradient is 12. So I can replace the g value with 12 because we know the gradient is 12. So 12 equals 3x squared. And then we're just going to solve this algebraically. X squared times 3 is 12. Well, since x is being squared, then multiplied by 3, we're going to divide 3, both sides by 3 first. 12 divided by 3 is 4, so 4 equals x squared. So what squared makes 4? Pretty easy. X must be 2, because 2 squared makes 4. But also, negative 2 squared makes 4. Negative 2 times negative 2 makes 4. So yes, there are two coordinates where the gradient will be 12. So let's say, let's say we know the x-coordinate of this point is 2, and we don't know what the y-coordinate is yet. And the x-coordinate of this point here is negative 2, and we don't know how to find a y-coordinate. Now we've defined the y-coordinate, because coordinates are always made up of an x point and a y point. So how do we do this? All you do, guys, is you're going to plug your x-coordinate back into the original equation, not into your dy over dx. So y is equal to x to the power of 3, and we're going to replace x with negative 2. So y is equal to negative 2 cubed. You put that into your calculator, it'll be negative 8. So this coordinate here is going to be negative 2, negative 8. So that's your first answer. And then we'll do the same thing for this coordinate here. So y equals x cubed. And I'm going to replace x with 2. So 2 cubed, which is 8. So this coordinate here is 2, positive 8. And these are the two coordinates at which the gradient is 12. Let us try the next question. Let's put this on the next page, actually, so we have more space. Next one. For the equation y equals 4x to the power of 3 minus 2x plus 5, find dy over dx. Oh, pretty straightforward. Let's just differentiate it. Okay, so y equals, in case you can't see it, 4x cubed minus 2x plus 5. We have to differentiate it. So dy over dx, pretty easy. 4 times 3 is 12. X, 3 minus 1 is 2. Minus 2x, x is by itself, so that cancels out. So minus 2. Plus 5, it just disappears. So that's dy over dx done. Find the coordinates of the 2 points on the curve where the gradient of the curve is 1. So we have our curve, 4x cubed minus 2x plus 5. Since the largest power is a 3, this is definitely a cubic graph. Boom, boom, boom. And we're trying to find the 2 points where the gradient of the curve is 1. So let's just say, I don't know, this point here looks like it has a gradient of 1. And maybe this point here. That kind of looks like it has a gradient of 1. So our goal is to find those two coordinates. So whenever we have a question about gradients and curved lines, we must differentiate. So we've done that in the first question. And then We can replace the phrase dy over dx with g, gradient. The gradient equals 12x squared minus 2, sorry. And we want to find the gradient on the curve. We want to find the coordinate on the curve when the gradient is 1. So we can replace g with 1. So 1 equals 12x squared minus 2. And then we'll just rearrange to find x. So x is being squared, then multiplied by 12, then subtracted by 2. So we'll work backwards. We'll add 2 to both sides. So 1 plus 2 is 3. 3 equals 12x squared. X is being squared, then multiplied by 12. So we'll divide by 12. That can be simplified. 3 over 12 is a fraction, which can be simplified to 1/4 equals x squared. And then what squared is 1/4? That's pretty tricky, so we'll solve it by algebra. How do you get rid of a square? We're going to square root both sides. So the square root of 1/4, and we're going to square root this. How do you square root a fraction? If you want to square root a fraction, you basically square root the numerator and square root the denominator. The square root of 1 is 1. The square root of 4 is 2, or it'll be negative 2. So our answers are 1 over 2 or 1 over negative 2. And square and square root cancel out. So those values are equal to x. So those are the x coordinates of these 2 points. So let's say for this point it'll be 1/2. And we don't know what the y coordinate is yet. And for this point here, it'll be negative 1/2. And we don't know what the y coordinate is here. Now, how do we find the y coordinate? What we're going to do is we're going to plug our x coordinate back into our original equation. So 4x cubed minus 2x plus 5, y equals, we're going to replace x and x with negative half. So y equals 4 times negative 1/2 cubed minus 2 times negative 1/2 plus 5. Where's my calculator? Here it is. So negative 0.5, 4. Our y coordinate, this makes 5.5. So this point here has a coordinate of negative 1/2, 5.5. So that's our first answer. And we'll do the exact same thing to this coordinate here. So, oh boy. Y equals 4x cubed minus 2x plus 5. We'll replace x with positive half, so half cubed minus 2 half plus 5. And what comes out? 4.5. So this coordinate here is going to be half 4.5. So these 2 coordinates have a gradient of positive 1. And if you want to practice, you can try this question over here. I'll make it a bit clearer so you can see. So it's y equals 2x cubed plus 3x squared, sorry, plus 2. And that's the exact same thing. 2x cubed plus 3x squared plus 2. Okay, guys, final chapter is all about turning points. Let's get started. A curve has equation y equals x cubed plus 3x squared minus 24x. Find dy over dx. All right, pretty straightforward. We have to differentiate it. Let's write our equation a little bit bigger. X cubed plus 3x squared minus 24x dy over dx equals x cubed means 1x cubed. 1 times 3 is 3x. 3 take away 1 is 2. Perfect. Next one. 3 times 2 is 6. X. 2 minus 1 is 1. So 6x to the power of 1, which is just 6x. And then minus 24x. Well, the x is by itself, so it just cancels out. So it's just going to be minus 24. And that question is all done. Part B. Find the coordinates of the turning points of the curves. In order to work around the idea of turning points, it's always best to just draw a picture, and the answer will come actually very, very clear. Well, let's just draw this graph out. X cubed plus 3x squared minus 24x. Since the largest power is a 3, this is going to be a cubic graph. And since it's positive x cubed, our graph will look like this. All right? And we're being asked to find the coordinates of the turning points. A turning point, guys, is where a graph goes from a positive gradient to a negative gradient, or from a negative gradient to a positive gradient, aka this point over here and this point over here. As you can see, the gradient here is positive, and then it slopes towards negative. And for this point here, the gradient before it is negative, and it becomes positive. So these are the turning points, where the gradients switch. Now, let's draw a tangent at both these points. So if I was to draw a tangent here, it'd look like this. It's a flat line. And over here, it's also a flat line. Since these lines are both flat, the gradients are 0. So the gradient is 0, and the gradient is 0. So remember guys, whenever we're discussing a curved line, and the question's referring to gradients, step 1 is you have to differentiate. Luckily for us, we've done it in the first question. Remember, and next, what can we replace dy over dx with? We can replace it with the word gradient. So the gradient is equal to 3x squared plus 6x minus 24. And since we know the gradient at these 2 points is 0, we can replace g with 0. 0 equals 3x squared plus 6x minus 24. And we can just solve this equation. So this is a quadratic. There's x squared, a single x, and a constant. So you can solve this by 2 ways. You can solve this by using the quadratic formula, or you can solve it by factorizing. I'll solve it by factorizing. First things first, I notice I can factorize out of 3. You can divide all 3 terms by 3. So 3 goes on the outside, x squared plus 2x minus 8. And now inside the brackets is a much easier quadratic because the a value is 1. So let's get our quadratic. Well, a is 1 because it's 1x squared. B is 2. And c is negative 8. So we have to find 2 numbers that multiply to negative 8 and add to the b value, so add to 2. So what plus what adds to 2, and what times what multiplies to negative 8. Sorry about that. Well, that's pretty straightforward. It's going to be 4 and negative 2. 4 and negative 2. So we can go ahead and open up 2 brackets. X positive 4 and x negative 2 equals 0. Don't forget the 3 in the front, although it's useless. So let's just write out the first bracket. So x plus 4 equals 0. What plus 4 is 0? Well, x must be negative 4. And then we'll do the second bracket. X minus 2 equals 0. What minus 2 is 0? Well, x must be 2. So we know the x coordinate of this point here is going to be 2. And this coordinate, x coordinate, is going to be negative 4. Now, we have to find the y coordinate. How do we find the y coordinate for each of these coordinates? Well, what you do is you're going to get your x coordinate and plug it back into the original equation, okay? So y equals x cubed plus 3x squared minus 24x. I'm going to plug 2 into x, okay? So y is equal to 2 cubed plus 2 squared minus 24 times 2. Y is equal to, let's figure that out. So 2 cubed plus 3, 2 squared minus 24 power of 2 times 2. I messed that up. 2 to the power of 3 plus 3, 2 squared minus 24, negative 28. So we know this coordinate here is 2, negative 28. That's our first answer. And you're going to do the exact same thing with negative 4. So you're going to plug negative 4 into this equation. So y is equal to negative 4 cubed plus 3 times negative 4 squared minus 24 times negative 4. Let's do it. Negative 4 cubed plus 3 times negative 4 squared minus 24 times negative 4. 80. So negative 480. And these are your two answers. Negative 480 and 2, negative 28. The next question, guys. The curve of equation y equals 8x squared plus 2 over x has one turning point. Find the coordinates of this turning point. Okay, so we have a curve, and we're trying to find the equation of the turning point. Remember, guys, the turning point is this point here, where it goes from a positive gradient to a negative gradient, or this point here, where a line goes from a negative gradient to a positive gradient. Now, remember, guys, if you were to draw a tangent at a turning point, you'll realize the gradient is 0. It's a flat line. So since this question is all about gradients and curves, we're going to have to differentiate, okay? So y equals 8x squared plus 2 over x. Remember, guys, in an earlier chapter, we hate differentiating with fractions. So we have to get rid of the fraction before we differentiate it. So y is equal to 8x squared plus 2. Since x is underneath, and x means x to the power of 1, to bring it back up, we'll do x to the power of negative 1. And now we can differentiate it. dy over dx equals 8 times 2 is 16. X. 2 minus 1 is 1, so 16x to the power of 1, which is just 16x. And then next it's positive 2 times negative 1, which is negative 2x. And then minus 1, subtract 1 makes minus 2. Now we can replace the phrase dy over dx with gradient. So the gradient is equal to 16x minus 2x to the power of negative 2. And we're trying to find the coordinates where the gradient is 0. So we can replace g with 0. 0 is equal to 16x minus 2x minus 2. Now, guys, whenever we're solving equations, we hate solving equations when we have a negative indice. So we have to put it back into a fraction. So 0 is equal to 16x minus 2x to the power of negative 2. So let's rewrite this so there's a fraction. So we get rid of the negative indice. 0 is equal to 16x minus 2x. Another way to write x to the power of negative 2 will be x at the bottom, and the 2 becomes positive. And then, now we can start solving it. So first things first, how can we solve this? Well, let's get rid of this fraction, divide by x to the power, divide by x squared. Let's get rid of divide by x squared. We're going to multiply by x squared. We have to multiply all the other terms by x squared. 0 times x squared is 0. 16x times x squared is going to be 16x to the power of 3 minus divide x squared and times x squared cancel out. 2. Then we can just rearrange it. So plus 2 plus 2. So 2 is equal to 16x to the power of 3. X is being cubed, then multiply by 16. So we're going to divide by 16. Divide by 16. So 2 over 16 is equal to The 16s cancel out. X to the power of 3. We can simplify this fraction to 1/8 if you want, is equal to x cubed. And then, how do you get rid of this cube? You can cube root both sides. So put this to your calculator. If you were to cube root 1/8, you'll get 1/2. So positive and negative half. Oh no, just positive half. Sorry. So the cube root of 1/8 is just half, and the cube root cancel out. So x equals 1/2. So that's our x coordinate. How do you find your y coordinate? Well, what you're going to do is you're going to plug this x value back into your original equation. So let's do it over here. Y is equal to 8x squared plus 2 over x. And we're going to replace x with half. So y is equal to 8 half squared plus 2 over half. And see what comes out. Six. And that is the coordinate of the turning point. 1/2, 6. Boom. Last question, guys. A few more tricky problems towards the end, perhaps. Identifying a maximum or minimum and the line of symmetry. Let's get started. First question. A curve has the equation of y equals x squared minus 4x plus 1. For this curve, find dy over dx. All right, pretty straightforward. X squared minus 4x plus 1, dy over dx. X squared means 1x squared. 1 times 2 is 2x. 2 minus 1 is 1, so 2x to the power of 1, which is just 2x. Minus 4x, well, x is by itself, so it's just going to be minus 4. And then plus 1, it's a constant, so it disappears. So yep, dy over dx is equal to 2x minus 4. Next question, find the coordinates of the turning point. All right, well, let's sketch this graph real quick. Since the largest power is a 2 and it's positive x squared, it's going to be a U-shaped graph. And we're trying to find this coordinate here. Well, this coordinate, if I were to draw a tangent, it has a gradient of 0. So we can replace dy over dx with g. So g equals 2x minus 4. And at our turning point, the gradient is 0. So we're going to replace g with 0. So 0 is equal to 2x minus 4. And we'll just solve it. Plus 4 to both sides, plus 4. So 4 equals 2x. 2 times what is 4? X must be 2. To find the y coordinate, we're going to replace x is equal to 2 back into the original equation. So y is equal to x squared minus 4x plus 1. And we're going to replace x with 2. So 2 squared minus 4 times 2 plus 1. Y is equal to 2 times 2 is 4, minus 4 times 2 is 8, plus 1. 4 minus 8 is negative 4, plus 1 is negative 3. So our coordinate is 2, negative 3. Now state with a reason whether the turning point is a maximum or a minimum. Well, since we've drawn our graph, guys, it's really obvious to see that this point is a minimum. It's at the bottom of the curve, okay? If we have a curve like this, the turning point would be a maximum, because the turning point is at the top of the curve. So this is a minimum, because you can say this is a positive quadratic, because this graph is x squared minus 4x plus 1. the x squared is positive x squared. If it was negative x squared minus 4x plus 1, then it would look like this, because the quadratic would be negative. But our quadratic is positive, so it is a minimum point. Now, find the equation of the line of symmetry of y equals x squared minus 4x plus 1. You guys, is you want to draw out your equation again. So it's a U-shaped graph. And if you were to draw a U-shaped graph, the line of symmetry just basically penetrates right down the middle. And the line of symmetry always cuts through the turning point. Our turning point was 2, -3. Now, our line of symmetry is a vertical line. All vertical lines start with x equals, okay? And since our x value is 2, our line of symmetry will be x is equal to 2. And that is our line of symmetry. Now guys, on the next page, here are some questions you can try in your own time. Here are 2 you can start by trying. And then you can try these 2 over here. And that's this video, okay? All about differentiation. Any questions or comments or concerns, just let me know. Thanks.